A statement from Neil deGrasse Tyson. What makes Proxima B intriguing is that it is an Earth-like planet circling the nearest star to the Sun. The James Webb Telescope has now taken the clearest picture ever of a planet, so like Earth that researchers can wonder. Proxima B is somewhere around 4 light years from us, and could be the first exoplanet that we people investigate with probes. After the stunning news about this planet, specialists are building numerous spaceships to actually look at who lives on Proxima B and whether these creatures are friendly. Proxima B is a special case among exoplanets. This planet is just somewhat more than 4 light years from us, making it one of the nearest heavenly bodies in the universe that isn't part of our local planetary group. The Proxima Centauri system has been bewildering researchers for a really long time. For quite a while, Alpha Centauri was believed to be our nearest heavenly neighbor. However, then surprises continued to happen. First, researchers figured out that Alpha Centauri is not an ordinary star at all. It is a double star. Years and years later, this strange system in our local cosmic area astonished us once more. Current stargazers, investigating space with truly further developing telescopes, once again found peculiarities in the Alpha Centauri system that astounded them. At long last, analysts found the justification for these oddities: a third star. However, the third in the Alpha Centauri system didn't give off the impression of being just a quavering of the definitely known star couple. The star was, and is, too prominent for that. Despite the fact that its orbit is directly linked to the other 2 stars, Proxima Centauri meanders far beyond the orbit of the other 2 during its movements through the universe. This drove researchers to the idea that the third star could be captured. The gravitational pull of Alpha Centauri A and B has captured a third star, and since then, the 3 have been moving in a common dance in the universe. The exoplanet Proxima Centauri B was found in 2016 as one of the primary near-Earth exoplanets. The find was a sensation. The James Webb Telescope is now uncovering the real essence of Proxima Centauri B. Proxima Centauri B could be the closest planet to Earth that is occupied. This is incredible because we might visit this world in the not-too-distant future. Proxima Centauri B would surely be one of our first destinations when we can build interstellar spaceships. Yet, we have even more thrilling facts about this. First, we should investigate the marvels of this planet, which is viewed as an Earth twin. Proxima Centauri B is undeniably greater than Earth and a bit denser. It has been clearly identified as a rocky planet, meaning that unlike gas planets, it has a solid surface. Furthermore, Proxima Centauri B orbits its star in a very close circle, so that a year on the planet lasts only 11 days. At first, this doesn't sound promising, because being so close to a star makes it very hot in our system. But in the Proxima Centauri system, it's different. The star is barely as bright as our Sun. This, of course, puts Proxima Centauri B in the habitable zone of its star. If the planet also has water, it could actually be an Earth-like planet with a mild climate and life. This is precisely where the James Webb Space Telescope comes in. Although the planet has been known for a long time, and there's been some speculation about its real nature, our technology could never determine whether Proxima Centauri B has an atmosphere and water. The goals of the Webb mission are clearly to find out these facts, not only regarding Proxima Centauri B, but also about many other exoplanets that are potentially Earth-like and habitable. Webb can use its unique technology to make the first accurate studies of the atmosphere of distant planets. To do this, the telescope uses a completely new kind of spectrometer technology that works with infrared light rather than light in the visible color spectrum. Infrared light beams can also be emitted by very distant or very faint celestial bodies, or rather, the light moves into the red color spectrum due to the long journey to us. What Hubble, which works exclusively with visible light, couldn't do, James Webb can now do with ease. Even the faintest signals from distant stars that have traveled billions of light years are captured by this new super telescope and converted into visible images. In the case of exoplanets, the technology provides us with precise data from a planet's environment on a vast scale. Exoplanets are like grains of sand or dust. They are tiny compared to their stars and cannot generate their own light. However, they reflect light, and scientists use this to find them. Imagine how an exoplanet first absorbs the illumination of its star, then it mixes with the planet's atmosphere and is reflected from the surface. All the light that we can see on Earth, and that gives us warmth, is sunlight that has been absorbed and reflected in just this way. During these cycles, the light from the sun is altered, and Proxima B changes the light from its star. If the light mixes with certain gases in the atmosphere, or even advances the reaction of the gases and heating cycles, it produces a fine but still detectable light spectrum. This spectrum contains hundreds or thousands of different light waves, and each gas and element produces its own well-distinguishable signature within the light spectrum. In plain language, this means that oxygen in the atmosphere of Proxima B produces similar frequencies to oxygen in the atmosphere of Earth. The same applies to water droplets in the atmosphere of a planet. Depending on how much water is measured in the planet's environment, scientists can then make further inferences about the amounts of water on the planet's surface. Life. Would you at any point have felt that there are other livable planets in the universe? Or were you one of those individuals who immovably accepted that we are the only ones in the universe and that the Earth is unique? To be clear, there won't ever be a planet that exactly looks like Earth. There aren't even two snowflakes that are the same, yet there are a few planets that are damn like Earth, and Proxima B is one of them. According to science, a genuine super-Earth is a bit bigger, a bit hotter, and slightly heavier than Earth. Such a planet would contain a lot of water and have harmoniously dispersed bodies of land. The environment would be mild and evenly warm, and the star would have about twice the lifespan of our sun. During this extended lifespan of the system, super civilizations could even form, according to evolutionary scientists. It's exactly such civilizations that we hope to find in the universe. Imagine we have a highly intelligent and technologically advanced society somewhere in our cosmic neighborhood, which, on top of that, is friendly and interested in contact. We could probably learn a lot from such beings. At the moment, this still seems far off, but engineers and scientists are working every second to master interplanetary and eventually interstellar space. They hope to reach Proxima B in just 20 years. If Yuri Milner, a Russian billionaire and space enthusiast, has his way, spaceships will be traveling to Proxima B in just a few years. The first of these miniature spacecraft will only have a camera and some moderate measuring instruments on board. However, the equipment should be sufficient to provide us with the first real photographs from the Proxima system and finally show us whether Proxima B is inhabited by life. Thanks to a special acceleration technology, these probes, which are only a few centimeters in size, will travel at nearly the speed of light and reach Proxima B in under 10 years. We could see the first photographs of an exoplanet as soon as the mid-2030s. We will see the planet's atmosphere in colors for the first time, and it will be a surprise to see whether Proxima B is blue, green, and white like our Earth, or brown, gray, or even red. Due to measurements from the best telescopes on Earth, we know that Proxima B probably has a bound orbit around its star. It has a day side and a night side. The day side is probably too hot for life, and it never gets dark there. The night side is always dark and probably freezing. The fascinating thing about this planet is a transition zone that stretches once all around the planet, and life could be possible there. It sounds crazy to us that a planet is livable only on a strip of a few thousand kilometers, and on one side, it goes either into eternal brightness and heat, while in the other direction, into darkness and cold. That wouldn't make the planet a true twin of Earth. As we continue our search for other life in space, we should also consider other possible forms of life that go beyond our previous definitions. This, of course, raises the astonishing question of whether we would then also be able to visit Proxima B ourselves. Yes, numerous researchers are confident that as we continue to advance today's state of technology, we will soon develop spaceships with engines that can reach nearly the speed of light. Trips to Proxima B would then likely be possible in around 20 years. However, we still don't know how we will solve issues such as weightlessness in space or the effects of cosmic radiation. All hopes in this regard are pinned on the development of the warp drive. This could enable travel through the space-time structure of the universe without the need for fuel. In theory, the drive, which we all know from sci-fi films like Star Wars, already exists. So far, however, we have been stymied by the energy issue. But here, too, there is continuous encouraging progress. In 2022, researchers from the USA succeeded in creating a small-scale warp bubble. This bubble can stretch space-time in such a way that material objects, such as spaceships and people, can essentially slip through a fold for travel over vast distances. We would then need hardly any time and equally little fuel. We just need to be able to create such a bubble on a large scale, and that will cost energy. The solution could lie in alternative energy, like negative matter, or even the mysterious dark energy. If the warp drive is successful, space travel will not only free us from time and space, but astronauts would also be freed from the stresses of cosmic radiation or effects like time dilation. Subscribe now to the feed. We are constantly publishing new, interesting videos.